This is a short video just to introduce the idea of the del operator. So the del operator, that's an upside down triangle. So del equals, well, it's the I component partial by partial x plus the j component partial by partial y plus the k component partial by partial z. So if we were to take the del component and we were to dot it with a vector function, then we would have this here, which is above, times the vector function, which would be I f of x plus j f y plus k f of z. So that means that the I would cancel with the j and the k, and the j would cancel with the I and the k would cancel with the I and the j. So you would just be left with the partial f of x by partial x plus partial f of y by partial y plus partial f of z by partial z, which is just the divergence of the vector function f. So we can then write div f in this form here, del dot f. So in terms of the electric field, we've seen that the divergence of the electric field is equal to rho upon epsilon naught. So we can then write the divergence of the vector field del dot E equals rho upon epsilon naught. So I've just repeated that down here. So there is the differential form of Gauss's law, del dot E equals rho upon epsilon naught. That's all there is for this video. In the next video I'm going to go on and we'll have an informal look at the divergence theorem, and that will finish off our videos on divergence. Okay, thank you for listening. If you enjoy this video, then don't forget to subscribe. Goodbye.